Scientists just confirmed something is changing beneath Yellowstone, and what they found next has researchers on edge. In July of 2025, GPS stations along the north rim of the Yellowstone caldera began drifting in a pattern scientists know all too well. By the end of the season, the ground in one part of the park had risen by nearly 2 centimeters, and satellite radar backed it up. On its own, that might not sound like much. But this is Yellowstone, where a few centimeters can be the surface whisper of something enormous moving far below. And the part scientists still cannot fully explain is why this exact area woke up again now. Right now, beneath the geysers, hot springs, and tourist boardwalks of Yellowstone National Park, the ground is not completely still. It never really is. Yellowstone is one of the most carefully watched volcanic systems on Earth, and for good reason. It sits above a gigantic reservoir of heat, fluid, gas, and partially molten rock that has shaped the landscape for hundreds of thousands of years. Every steaming vent, every boiling pool, every sulfurous breath rising through the cold morning air is part of that hidden engine. Most days, that engine behaves like a restless giant in its sleep. It shifts, it exhales, it releases pressure in small ways. And then, every now and then, the data begins to hint that something under the surface is reorganizing itself. That is what makes Yellowstone so unsettling. The danger is not that it looks dramatic every second. The danger is that it can seem calm while the real story is happening underground, out of sight, traced only by instruments, seismic waves, gas measurements, and tiny movements in the earth that no visitor would ever feel with their own feet. A family can stand at a railing near a bright blue spring, hear nothing but wind and distant water, and have no idea that miles below them, the crust is flexing, fluids are moving, and scientists are staring at graphs that suddenly no longer look normal. The new concern began in a place that has troubled scientists before. Just south of Norris Geyser Basin, along the north rim of the caldera, there is a zone that rose noticeably from 1996 through 2004. Back then, that patch of ground lifted by about 12 centimeters in total. It later subsided, then mostly settled down, then went quiet enough that it became just one more chapter in Yellowstone's long history of strange behavior. But in July of 2025, the pattern returned. Continuous GPS stations on the northwest side of the caldera began moving away from that same area. At first, the signal was murky because it appeared around the same time as normal seasonal movement. Then, more data came in. Semi-permanent GPS stations near the center of the anomaly showed that between July and September, the ground had risen by almost 2 centimeters. Satellite radar covering the period from October 2024 to October 2025 showed uplift in almost the same shape as the earlier event. That was the moment this stopped looking like noise and started looking like a repeat. Scientists gave this area a name years ago. They call it the Norris Uplift Anomaly. The name sounds clinical, almost harmless. But what it really means is this. A part of Yellowstone's crust is bulging upward again, in a place that has already shown it can respond to forces deep below the surface. The simple question is obvious. What is pushing it up? The honest answer is much less satisfying. Researchers have ideas. They have models. They have comparisons to past episodes. But they do not yet have a single clean explanation for why this uplift returned when it did, how long it will last, or exactly how the deep magmatic system, the shallow hydrothermal system, and the surrounding faults are interacting, and that uncertainty is where Yellowstone becomes most compelling. Because the ground did not just rise. As the uplift returned, seismicity in the area also ticked upward. Yellowstone usually has plenty of earthquakes. In an average year, the region sees around 1,500 to 2,500 small quakes. That alone tells you this place is alive. But in late 2025, a swarm of more than 100 earthquakes appeared near the uplift zone, especially in November. The largest reached magnitude 2.7. None of these were large enough to cause major damage. None of them meant an eruption was suddenly about to happen. But they mattered for another reason. They suggested that the crust in that area was adjusting to stress. Something below was pushing, the rock above was responding, and the instruments could see the conversation happening between pressure and stone. That is the part many people miss when they think about Yellowstone. They imagine one giant magma chamber sitting under the park like a bomb waiting for a timer to hit 0. That is not what scientists see. What they see is more complicated and in some ways more eerie. Yellowstone is not a single solid tank of liquid magma. It is a messy system of partially molten rock, trapped gases, fluids, fractures, porous zones, heat pathways, and hydrothermal plumbing that reaches close to the surface. It behaves less like a single explosive container and more like a living industrial complex buried in the crust. Pressure builds in one place, gas leaks through another, water circulates, heats up, flashes to steam, and sometimes finds a violent way out. The whole system breathes, slowly, unevenly, and at times, unpredictably. That word matters here. Breathes. In 2025, researchers using a powerful seismic imaging survey revealed one of the clearest pictures yet of what lies beneath Yellowstone. They identified a sharp, volatile ridge cap, about 3.8 kilometers below the surface. In simple terms, they found a kind of lid near the top of the magma reservoir. This cap appears to contain partially molten rock mixed with bubbles of supercritical water. That may sound abstract, but the image is striking. Imagine a deep, pressurized body of hot material covered by a sponge-like layer full of heat and gas. Not a sealed iron lid, not a wide-open vent, something in between. A barrier that traps pressure, but also leaks it. Researchers believe that is one reason Yellowstone has remained stable. The system appears to be venting gas through cracks and channels rather than allowing pressure to build unchecked. One scientist compared it to steady breathing. Yellowstone, in that view, is not holding its breath before a blast. It is exhaling, bit by bit, through the vast field of hydrothermal features that cover the park. Every steaming vent and roiling spring may be part of that pressure release system. That should be reassuring, but it also raises a bigger question. If Yellowstone is breathing, why did the ground near Norris begin swelling again? And what happens when the breathing pattern changes? This is where the story becomes stranger. For decades, scientists knew there was magma beneath Yellowstone, but the upper boundary of that reservoir remained uncertain. Some estimates placed it deeper, some shallower. The new imaging survey used a massive vibrosis truck weighing about 53,000 pounds to send controlled seismic waves into the ground at night from roadside turnouts inside the park. More than 600 seismometers recorded the returning signals. Through all the noise of Yellowstone's complicated geology, researchers finally picked out a strong reflector at about 3.8 kilometers depth. That reflector was a surprise. It suggested a sharp boundary where the physical properties of the subsurface change abruptly. In plain language, they found the top of something active. Not active in the sense of imminent eruption. That distinction is crucial. Scientists say the bubble and melt content they detected are below levels usually associated with a near-term eruption. But active enough to matter. Active enough to show that Yellowstone's magmatic system is not some frozen relic left behind by ancient eruptions. It is still dynamic, still moving gas, still shifting heat, still influencing the land above. The reservoir has not shut down. It is not dead. It is simply operating on timescales so vast and forces so immense that human intuition struggles to grasp them. And while that deep system appears to be venting pressure in a stable way, the shallow system above it is anything but quiet. Yellowstone's hydrothermal landscape is the visible face of the hidden engine below. It is the place where deep heat meets groundwater and expresses itself on the surface in the most beautiful and dangerous forms imaginable. The park contains the largest and most diverse collection of thermal features on Earth. More than 10,000 hot springs, geysers, mud pots, fumaroles, and warm ground areas are scattered across the region. These are not decorations. They are the skin of the volcano. They are how the buried heat system touches the world above. And that skin has been changing. In April of 2024, a small hydrothermal explosion occurred in the Porcelain Terrace area of Norris Geyser Basin. No tourists saw it. No dramatic footage spread online that day. The park was seasonally closed, but newly installed monitoring equipment recorded it. In fact, it became the first hydrothermal explosion in Yellowstone ever detected instrumentally. The signal lasted about a minute. It left a crater a few meters across and disturbed the surrounding ground. That matters because hydrothermal explosions are one of Yellowstone's most immediate hazards. They do not require fresh magma rising to the surface. They can happen when pressurized hot water suddenly flashes into steam and violently blasts rock, mud, and debris outward. In a place filled with visitors, boardwalks, and viewing areas, even a relatively small explosion can become a serious danger. Then came a much larger reminder. On July 23rd of 2024, Black Diamond Pool and Biscuit Basin erupted in a hydrothermal explosion powerful enough to destroy part of the boardwalk. Water, mud, and rock blasted into the air. The area had to be closed. Later, new monitoring systems and webcams documented numerous smaller eruptions from the same pool. In June of 2026, another small hydrothermal explosion occurred in Biscuit Basin, opening new vents and throwing rocks several meters into the air while sediment-rich hot water temporarily discolored the Firehole River downstream. Again, not apocalyptic, but not trivial either. These were surface reminders that Yellowstone's plumbing is active, unstable in places, and capable of rearranging itself suddenly. Now, put those pieces together. A volatile ridge cap sits a few kilometers below the surface, apparently releasing pressure in a kind of steady breathing. Above that, hydrothermal features shift, new pools form, geysers change behavior, and occasional explosions tear open the crust with almost no warning. At the same time, the north rim of the caldera begins lifting again in a pattern similar to one seen decades earlier. Earthquake swarms flicker in the same area. Scientists can say with confidence that Yellowstone is at normal background alert levels, They can also say with confidence that the system is dynamic and the causes of some recent changes are still being worked out. That gap between normal and understood is what keeps experts watching so closely. Because normal at Yellowstone does not mean stillness. It means movement within known bounds. It means a region where dozens of small earthquakes can happen in a week without implying disaster. It means the ground can rise and fall by centimeters or more over months or years. It means thermal areas can awaken, fade, migrate, and rupture as the underground plumbing shifts. Yellowstone's normal is more active than almost anywhere else, and that makes the return of an old uplift anomaly deeply interesting, even when it is not immediately alarming. The reason this matters goes beyond academic curiosity. Yellowstone sits beneath one of the most famous landscapes in the world, visited by millions, surrounded by communities, roads, lodges, infrastructure, and ecosystems that depend on stability near the surface. A subtle shift underground is not just a graph line bending upward. It is a change in the foundation of a living landscape. If the uplift is tied to magma accumulating at depth, that tells scientists something vital about how the deep system is evolving. If it is tied to hydrothermal fluids moving upward or sideways through fractures, that tells them something equally important about near-surface hazards. If it is a mixture of both, then Yellowstone may be reminding everyone that its magmatic and hydrothermal systems are not separate stories at all. They are different parts of the same machine, and that is where the real unease begins. Because for years, Yellowstone has been monitored with an expanding network of GPS stations, seismometers, gas studies, radar satellites, webcams, and chemical sampling. The tools have gotten better. The images have gotten sharper. Scientists can now detect motions that would have been invisible a generation ago. They can track horizontal drift in the crust to the scale of millimeters. They can spot subtle deformation from space. They can hear unwitnessed explosions through infrasound arrays. Yet even with all of that, Yellowstone still produces moments that resist a full explanation. Not because science is failing, but because the system itself is staggeringly complex. Think of it this way. Imagine trying to understand a giant buried city by listening through the pavement. You hear pipes rattle, you hear distant machines turning on and off. You feel one neighborhood rise by a fraction of an inch while another settles. Steam escapes from vents blocks away. Somewhere underground, water is flooding a corridor. Somewhere deeper, hot gas is collecting in porous rock. The city is huge. The sounds overlap. Some changes are harmless, some are warnings. The challenge is not just hearing them. The challenge is knowing which ones belong together. That is Yellowstone. The Norris area is especially important because it sits near one of the most thermally active and geologically restless zones in the park. Norris Geyser Basin is already famous for extreme heat, acidic waters, and rapidly changing features. Steamboat Geyser, the tallest active geyser in the world, has had bursts of frequent eruptions in recent years, though its activity declined again in 2025. Nearby thermal ground can change color, crack, slump, or produce entirely new pools. In late 2024 and early 2025, a new blue water pool developed in Porcelain Basin. These visible changes are not random decorations. They are hints that the shallow system is continually reorganizing itself. So when uplift restarts just south of Norris, it is hard not to wonder whether deeper processes are once again feeding changes closer to the surface. Scientists are careful here, and for good reason. They do not say the uplift is a sign of an impending eruption. In fact, they stress the opposite. The deformation is minor compared with what is seen at some other caldera systems. The rates have not accelerated dramatically. Yellowstone's overall activity remains at background levels. By mid-January of 2026, the uplift that started in July 2025 had ceased, and there was little net deformation afterward. That matters. It tells us the episode, at least for now, did not continue growing into something larger. But a stopped episode is not the same thing as a solved mystery. The pulse may have ended. The question of what caused it remains. Some scientists think the earlier Norris uplift from the late 1990s into the early 2000s was caused by magma accumulating about 14 kilometers beneath the surface. Later deformation, closer to Norris during 2013 through 2020, appears to have involved shallow hydrothermal fluids accumulating and then being released. In 2014, that area experienced one of the fastest deformation rates ever recorded in Yellowstone, more than 15 centimeters per year, along with increased seismicity and a magnitude 4.8 earthquake. After that quake, uplift flipped into rapid subsidence. The interpretation was that hydrothermal fluids had built up and then escaped. Now the same broader region has moved again. So what is happening this time? Is deep magma once more altering stress in the crust? Are fluids released from rising magma accumulating in a shallower zone and pushing the ground upward? Are fractures opening and redirecting hot water and gas? Are earthquake swarms responding to that movement or helping to create pathways for it? Researchers are still trying to determine that. And that phrase matters because it is not a dodge. It is the precise edge of current knowledge. The easy version of the Yellowstone story is always the same. Supervolcano, doomsday, end of civilization. But the real story is far more interesting and in some ways more unnerving because it is not a cartoon explosion waiting for a single moment. It is an active Earth system quietly rewriting itself under a famous national park in real time. The question is not simply whether Yellowstone erupts tomorrow. It almost certainly does not. The deeper question is how a massive volcanic system stays alive for millions of years without crossing the line into a major eruption, and what signs appear when its internal balance shifts. The newly imaged magma cap may be one of those balancing mechanisms. If that porous, volatile-rich layer really does function as a pressure release valve, then Yellowstone's surface features are part of a giant planetary breathing apparatus. Gas separates from magma, rises through the crust, and escapes through cracks, channels, and hydrothermal fields. That would explain why such a large volcanic system can remain active without constantly escalating toward disaster. But no breathing system is perfectly steady forever. Channels clog, fluids reroute, pressure redistributes. The same cracks that relieve stress can change over time. The same hydrothermal network that keeps the system vented can create local hazards when water gets trapped and flashes to steam. That is why what is happening beneath Yellowstone is not just one mystery. It is several overlapping mysteries. One is deep. A reservoir of heat and melt remains active below the park, closer to the surface than some earlier estimates suggested. Another is shallow. Hydrothermal features are changing and explosions can happen with little warning. Another is structural. Specific parts of the caldera rim continue to rise and fall over years to decades. Another is mechanical. Earthquake swarms repeatedly appear in areas undergoing deformation, suggesting a two-way relationship between pressure and fracturing. Every one of these mysteries connects to the others. But the exact links are still being mapped out, and this is where the human side of the story matters. Because Yellowstone is not just a geological object in a textbook, it is a place where people drive through with children in the back seat. It is a place where hikers step off a road into a field of steaming vents, where tourists lean over railings to photograph rainbow pools, where workers maintain trails and lodges on top of one of the most unusual crustal systems on the continent. Protective instinct kicks in naturally when you realize the beauty of Yellowstone is not separate from its danger. The same heat that paints grand prismatic spring in impossible colors is the heat moving through that buried system right now. The same steam that makes the landscape feel alive is proof that pressure is constantly finding ways out. That should not cause panic, but it should command respect. And perhaps that is why Yellowstone holds such a grip on the imagination. It compresses timescales in a way few places can. On the one hand, its biggest eruptions belong to the deep past, separated from us by hundreds of thousands of years. On the other hand, its most immediate changes happen right now, in days and months and seasons. A pool forms, a vent collapses, a geyser quiets, a crater appears where no crater was before. A GPS station notices the ground has moved. A seismic swarm starts under a place tourists visited last week. You are forced to hold both truths at once. The system is slow beyond human comprehension, and also restless on a human timescale. That tension is what turns a few centimeters of uplift into a story worth watching. Because those centimeters are not really about height, they are about communication. The ground is speaking in small increments. Yellowstone never sends a polite summary, it sends fragments. A swarm here, a bulge there, a new thermal vent somewhere else, a fresh seismic image from below. Scientists collect those fragments and try to decide whether they belong to a single sentence or several different conversations happening at once. And lately, the fragments have been unusually revealing. The rediscovered uplift pattern near Norris tells us that old zones of activity can wake back up. The earthquake swarm on top of the uplift suggests the crust is adjusting to pressure changes. The new imaging of the magma cap shows the deep system is still active, but not obviously primed for eruption. The hydrothermal explosions in Norris and Biscuit Basin remind us that Yellowstone does not need a major magmatic event to produce dangerous outbursts at the surface. These are not isolated curiosities. Together, they paint a picture of a giant volcanic system that is managing its pressure, venting its gases, and yet still capable of sudden local surprises. Some scientists now believe this is exactly the kind of information Yellowstone has been hiding in plain sight for decades. Not a single countdown to catastrophe, but a complex choreography of deep magma, shallow water, trapped gases, porous rock, and shifting stress fields. The park's surface is the visible edge of that choreography. The uplift is one step in the dance. The quake swarm is another. The hydrothermal explosions are another. The breathing magma cap may be the rhythm underneath them all. But if that is true, then there's still one problem. The choreography keeps changing. In 2025, overall earthquake activity in Yellowstone was actually low compared with typical years. That alone should puncture the idea that every strange reading means immediate disaster. Yet even during a relatively quiet seismic year, new thermal features formed, subtle uplift began in a known anomaly zone, and hydrothermal activity remained lively enough to keep scientists adding instruments and cameras. In other words, Yellowstone does not need to look extreme across every measurement at once to deserve attention. Sometimes the most important signal is not that everything is going wrong, it is that one familiar signal returns in a place where it has meaning. That is why the phrase "something is happening beneath Yellowstone" is both dramatic and true. Something is happening. The question is, what kind of something? If the answer is mostly pressure redistribution in a system that routinely flexes and vents, then this episode may become another valuable case study in how Yellowstone stays stable. If the answer involves deeper magma, subtly changing the stress state of the North Caldera Rim, then scientists may be seeing the earliest stage of a process that unfolds over years, not days. If the answer involves hydrothermal fluids collecting in response to deeper changes, then surface hazards in places like Norris may become even more important to monitor. None of those scenarios means the supervolcano is about to erupt, but every one of them matters, because every one improves our ability to read the next signal. And reading the next signal is the entire game. At Yellowstone, the true danger is not only what happens, it is what happens without context. A hydrothermal explosion in a closed basin may go unwitnessed unless sensors hear it. A few millimeters of horizontal movement can mean nothing to a tourist and everything to a geophysicist. A 2-centimeter rise over part of a season sounds tiny until you realize it maps a force field underground. That is why the monitoring network matters so much. It is Yellowstone's early warning grammar. Without it, the park would still be changing. We just would not know how to interpret the changes until much later. There is also a deeper emotional truth here, one that makes Yellowstone feel bigger than a single national park. It reminds us how thin the surface of our world really is. We live as if the ground is the stable part of life, the unquestioned platform under roads, homes, and plans. Yellowstone strips that illusion away. It shows that beneath some landscapes, the crust is not a platform. It is a lid, a warm, cracked, moving lid above forces old as the planet itself. The beauty of the park comes from that fact. So does the risk. So does the awe. And maybe that is why this story lingers. Not because scientists found proof of imminent doom. They did not. Not because the park is secretly about to explode. There is no evidence of that. It lingers because the new readings tell us Yellowstone is active in ways we are only beginning to resolve clearly. The earth under that park is adjusting itself right now. It is lifting in old places. It is releasing gas from deep, porous layers. It is rearranging hot water close to the surface. It is producing earthquakes where stress is changing. It is doing what living volcanic systems do, and it is doing it in our lifetime, under one of the most recognizable landscapes on the continent. For anyone paying attention, that should create a certain kind of vigilance. Not panic, not sensationalism, vigilance. The kind that respects subtle warnings. The kind that understands nature rarely shouts first. Yellowstone speaks in instruments before it speaks in spectacle. The GPS station notices before the visitor does. The infrasound array hears the blast before anyone sees the crater. The satellite catches the bulge before the ground looks any different at eye level. The science comes first. The drama often follows later. So what should people actually watch for? Not viral rumors about animals fleeing the park. Those stories surface again and again and are not reliable warning signs. Not every small earthquake headline. Not every social media clip of steam rising from a pool. What matters more are patterns confirmed by monitoring. Sustained changes in deformation, accelerating earthquake swarms, significant shifts in gas release, new or repeated hydrothermal disturbances in active basins. Yellowstone is watched closely enough that real changes do not stay hidden for long. The challenge is less about finding information and more about understanding which pieces fit together. And right now, the clearest pattern is this. A known uplift zone south of Norris reactivated in 2025. The area rose by almost 2 centimeters over part of the summer and early fall. Horizontal GPS movement and satellite radar confirmed the change. Seismicity increased nearby, including a swarm of more than 100 quakes late in the year. Scientists say the system remains at background activity and that an eruption is very unlikely. At the same time, they also say they do not yet know exactly what will come of this deformation episode. That combination of confidence and uncertainty is not a contradiction. It is the most honest reading possible. Yellowstone is not suddenly becoming something new. It is revealing more of what it has always been, a colossal thermal machine. A volcanic system with a long memory. A place where deep magma, shallow water, and fractured crust negotiate continuously beneath forests, rivers, roads, and boardwalks. A place where the absence of catastrophe does not mean the absence of motion. A place where even good news comes with a warning label because stability itself may depend on processes that have to keep working just right. The breathing has to continue. The cracks have to vent. The pressure has to keep finding ways out. And if one day those pathways change more dramatically, scientists will want to know as early as possible. That may be the biggest reveal of all. The mystery beneath Yellowstone is not simply what terrible event might happen someday. It is how this immense system avoids terrible events for so long while staying unmistakably alive. The uplift, the quake swarms, the hydrothermal explosions, the newly imaged magma cap, all of them point to a system that is not sleeping in the way most people imagine. It is active but regulated, powerful but constrained, dangerous but not in the simple cinematic way people expect. The hidden story is one of balance. And balance, especially inside a volcano, is never a permanent achievement. It is an ongoing process. That is why researchers keep returning to the same place, the same data sets, the same questions. Why here? Why now? Why that pattern? Why did the uplift stop in early 2026? Why did it return after years of relative quiet? How deep is the driver? How directly are the hydrothermal and magmatic systems linked? How much gas is escaping? How much is being stored? Which cracks are releasing pressure and which might be trapping it? Those questions are not signs of ignorance. They are signs that Yellowstone is finally being seen in sharper detail than ever before, and the sharper the picture gets, the stranger the mountain underneath begins to look. Because what scientists have uncovered is not a simple chamber of molten rock waiting for a trigger. It is a layered, breathing, pressurized world under the park. A volatile rich cap, only a few kilometers down. A deeper magmatic source below that. Fractured crust flexing along the caldera rim. Water and gas moving through porous rock. Earthquakes marking where stone gives way. Explosions that can happen not because magma erupts, but because water does. The Yellowstone people think they know from postcards and summer road trips is really the roof of a giant hidden system still writing its own rules. And maybe that is the most unsettling part. Even with all the sensors, all the satellites, all the models and maps, Yellowstone can still produce a sentence science has to say out loud more often than people expect. We know something is happening. We just do not fully know why yet. So the ground beneath Yellowstone keeps being measured. The signals keep being compared. Scientists keep watching the North Rim, Norris Geyser Basin, Biscuit Basin, the seismic network, the GPS records, the thermal basins, the gas pathways. They are not watching because they expect the worst tomorrow. They are watching because the system is active today, because the story is unfolding now, because every new pulse of uplift, every new crater, every new image from below helps answer one question while opening another. And somewhere under the steaming terraces and bright mineral pools, Yellowstone is still breathing. The pressure is still finding paths upward. The crust is still adjusting. The old anomaly has already shown it can return. The shallow basins have already shown they can erupt without warning. The deep reservoir has already shown it is closer and more dynamic than some earlier estimates suggested. None of that proves catastrophe, but none of it allows complacency either. For now, the alert level remains normal. The park remains open. Families still gather at overlooks. Steam still rises in the morning cold. Bison still cross the roads. The landscape still looks, to most eyes, exactly as it should. But beneath that familiar surface, something is happening beneath Yellowstone that scientists are still trying to fully explain, and the next clue may already be moving through the ground.